Thank you for attending my session. And this is my second time for attending CodeBeam in person. I feel very happy to be back in San Francisco and as a presenter. It's a great honor to share our research activity with CodeBeam community. First of all, I would like to introduce collaborators and contributors to this work. Shintaro Hosoai is a project researcher in my laboratory, and Ryota Kinukawa is an awesome engineer at Tombow Works. You may know him as Pojiro-san. In my opinion, Pojiro-san is one of the most fantastic contributors to nervous ecosystems as well. And Shunsuke Kikuchi is a senior researcher at Sakura Internet, one of the famous cloud companies in Japan. This achievement and my presentation would not have happened without their help. Thanks so much for their contribution. And let me introduce myself. I am Hideki Takase. I principied my account Takase Hideki on Twitter, Facebook, or GitHub. Twitter is the best place to follow me. These presentation slides have been posted to my Twitter account. My research mission is to establish a cutting-edge platform and design methodology for embedded and IoT computing. I'm mainly organizing two R&D activities. The first is D3AI, funded by JST Crest. D3AI stands for Distributed, Dynamic, and Diverse AI System Technologies. We are currently working on federated learning as a state-of-the-art distributed learning methodologies. And the second is Beyond.ex, funded by NICT. This project aims to establish comprehensive runtime platform in a widely distributed IoT system with a functional language, Elixir. Okay, let's start my presentation. In this session, we consider node communication in Elixir and ARM. First, I want to explain what methods we want to try. Please imagine that two computers are in the same network, and they want to communicate with each other. The router assigns local IP addresses to them, and they know each other's IPs. In this case, Node Connector is suitable to connect them in the network. Node Connector is a very useful feature to implement distributed systems. By specifying the node name and IP address, communication can be handled as if the node were running on the same computer. But please consider the case where you don't know the computer's IP address in the network. How can we communicate with such a node without its IP? This is the first concern we want to try. In the next case, we consider connecting a node on a computer in another network. If the computer has a global IP address, such as a server, Node Connector works fine to connect them. Also, Node B1 can connect with Node B0 because they are in the same network. However, do you think Node A1 and Node B1 could connect as a node? I'm sorry, but I don't fully understand Node well, but I guess they cannot connect because of the overlapping partition. It may be possible to use Phoenix PubSub for this communication. Nevertheless, the concern we want to try here is to allow these nodes to communicate beyond NAPT as lightly as possible, since some of the computers are small. The final concern we want to achieve is the communication with node A3 and node B3. These computers are on different networks, and of course, they don't know each other's local IPs. In such a situation, we want these nodes to communicate easily and autonomously. So we want to introduce one solution. First, let's apply the magic of ROS2 on Elixir. As I will explain later, ROS2 has a feature to achieve autonomous node communication. We are working on Rclex, a library that integrates the power of ROS2 with Elixir. I presented this library at CodeBeam America, which was held virtually last year. So if you are interested in its library, please check out the slides and YouTube for more detail. As a second topic, I would like to share that we were able to run this Rclex on NURBS. The issue for ROS2 was its strong dependency on native Linux features, but we found a way to solve this. Third, I will share a protocol called Zeno. More details will follow, but we have confirmed this software is the best way to achieve our solution. Step 1 to achieve our purpose is Rclex. The integration of Elixir and ROS2 enables autonomous node communication, but only within the same network. This step will provide an overview of ROS2 and Rclex. ROS2 is a platform for accelerating the development of robot systems. This is one of the most famous pictures that expresses the concept of ROS. There are 4 features for ROS: plumbing, tools, capability, and ecosystems. Plumbing means a messaging infrastructure for robot systems. You might think that ROS is a kind of operating system, but it is not correct. The essence of ROS is a middleware for publish-subscribe communication. And also, ROS provides powerful tools to support robot development. Capability means a broad collection of library. Finally, the ROS project is organized by the worldwide open source community. As a plumbing feature, ROS provides a pub-sub-based asynchronous communication mechanism as a middleware. It is designed to support the quick and easy construction of distributed computing systems. The computational unit in the ROS application is expressed as a node. ROS node can communicate their data through a topic. I feel it is similar to Elixir and Alan. ROS application can be developed by combining nodes. Any node can publish messages, and any node can subscribe to messages. Okay, let's dive into the node communication mechanism about ROS2. ROS2 employs Data Distribution Service, DDS, as a communication middleware. There is RTPS as a communication protocol of DDS. RTPS has a simple participant discovery protocol, SPDP, and simple endpoint discovery protocol, SEDP. SPDP can search for communication partners with each other, and SEDP establishes communication paths. Here, after all this time, we define what we mean by autonomous. Autonomous means that the node can find a communication partner without a broker or agent. In addition, only the topic name and message type are required to specify the communication path. Once a node is registered as a publisher or subscriber via topic information, the node communication route is established flexibly. However, ROS2 and DDS have some limitations in communication. The first is that it's heavily dependent on native Linux functionalities. Ubuntu has been a most well-known target, but the size of platform to be installed is also larger. The second limitation is that ROS2 node must be on the same network. Since SPDP and SEDP are performed on the IGMP multicast packet, this is a natural limitation to prevent packet congestion. Here, we are working on the development of Rclex, a ROS2 client library for Elixir. This library allows robot engineers to develop robots in Elixir. For alchemists, this means that it is now possible to develop IoT systems that take advantages of DDS capabilities. This is a simple example code for the publisher node implemented with Rclex APIs. First, create nodes API will create a node with its name and the number of nodes. You can spawn loss nodes massively at the same time according to the value of num nodes. And also, you can select the topic number by the option of create publishers. Then you need to set the callback function and its operational interval by Rclex.time module. Please note that you can describe the node creation procedure with a pipe operator. In the callback function, you can efficiently create the list of messages for each node using the Elixir enum library. Finally, you can publish messages from lightweight Rclex nodes. This is an example of operation of Rclex. Two terminals on the left are the default ROST environment on x64 laptop computer. The node on the top left is implemented in C++ and publishes string type message to the topic. The node on the bottom is implemented in Python, subscribing to the topic's message. In this example, we used ERT3+ for the target of Rclex. This board is provided by Yokogawa Electric, mainly for the industry domain. The top right for Rclex creates 5 publishers, and the bottom creates 3 subscribers. One of the key features of Rclex is the ability to create a large number of nodes at the same time. Because Elixir's process is lightweight, we believe this feature will improve the scalability of ROS2 system. Okay, let's move on to step 2. The purpose of this step is to let Rclex running on NURBS. As I explained earlier, ROS2 and DDS are implemented with a strong dependency on native Linux. So it was not easy to make Rclex working on NURBS as is. But we got it and acquired a bare minimum and bulletproof runtime platform, the Rclex application. Through this activity, we have learned useful techniques for customizing the NURBS system. So we want to share our experience with your NURBS project. Maybe I don't need to explain how awesome NURBS is. NURBS is scalable, highly reliable, adaptive, secure, and agile platform for IoT systems. Instead, I want to introduce NURBS JP, a user and developer community in Japan. At present, almost 200 people join this community from all over Japan, and some Japanese-speaking members join from overseas. We hold an online meetup about once a month. Our goal is to spread NURBS technology in Japan. As a result, the first product with NURBS appeared in Japan. This is Pocket Launcher. Pocket Launcher is a device that bridges your in-house PC and field devices. By connecting this box and the equipment at the development site with a LAN cable and setting up the connection to your mobile Wi-Fi, you can connect your in-house PC and the equipment at site as a LAN. And also, we want to share our activity to port NURBS to new target. We are porting NURBS runtime on 2 boards with heterogeneous SoCs. The first board is Seed Odyssey STM32MP1. This SoC contains Cortex-A7 dual-core and M4 core. And the second is AMD Xilinx KR260, which has Cortex-A53 quad-core and FPGA logic. Both NURBS systems are already published at HexPM. Please try them if you are interested. Why do we want to operate NURBS on heterogeneous SoC? We are developing technologies enabling NURBS to utilize low power and real-time core or FPGA logic actively. But this work is very work in progress. If we can come up with something good to profit, I would like to share them at the next conference. So let's go back to the main topic, how to install ROS2 for Rclex on NABs. We have implemented a project that achieved this and have published it in our GitHub repository, along with samples and detailed instruction. The main idea is to use Docker container and RootFS overlay for NABs. Since ROS2 is also time-consuming for the installation, we thought it was not reasonable to ask Elixir developers to prepare a ROS2 environment to install Rclex on NABs. Actually, not many ROS2 libraries are needed just to operate Rclex. In other words, we only need to copy these necessary libraries to the NABs file system. For this reason, we have prepared a mix task, mix rclex.prep.ros2, to temporarily deploy the Docker container for ARM64 and copy the necessary directory to the RootFS overlay of the NABs project. And note that mix rclex.gen.msg in the fifth instruction is a command to generate type support and related functions to use ROS2 message type in Rclex. This is an essential process for using Rclex. Okay, this is the final step. This step introduced Zeno, an eloquent, scalable, and fast protocol. Zeno allowed us to achieve our ultimate purpose of autonomous node communication between different networks. The name Zeno comes from the Zero Overhead Network Protocol. Eclipse Foundation and Zetascale actively maintain this open source software. Zeno is a pub/sub query protocol that unifies abstractions for data and computation. And Zeno is entirely written in Rust for security and performance. There are three aspects of Zeno. Eloquent means first-class abstraction for messaging, storing, and querying distributed applications at any scale. In addition, Zeno and its implementation are decentralized and can scale out as well as scale down. Finally, Zeno is fast to run and extremely performant. To better understand Zeno, I picked up the few slides from a presentation at ROSCON 2 weeks ago. Using Zeno, any form of topology can be configured, including P2P, brokered, rooted. Zeno has a router module that handles message communication between different networks. Although we have not tried it yet, routers can be connected to each other to configure complex topologies. And Zeno run everywhere. Libraries for various languages have already been released, such as Rust, Python, and C. They also provide a client library for microcontroller. And for your information, no one seems to be working on a library for Elixir and Erlang yet. We focused on Zeno this time because we noticed that Zeno had already provided plugin for mapping DDS messages. We thought this could work with Rclex. And he is Julian, a senior technologist at Zetascale. He provided me with these slides and graciously allowed me to use them here to introduce Zeno. A video recording of his presentation at ROSCON is already available on YouTube. Please check the details if you become curious about Zeno. Well, how to use Zeno with Rclex on NABs. This method is also detailed in our repository. As mentioned earlier, Zeno is implemented only in Rust. both routers and client can run only in statically linked binary. To run Zeno's bridge for DDS on a computer, simply specify the router's IP and port number as arguments and run it in the background. To operate these on knobs, we turn to use of mount trap. This will allow the executable to be run as a demo in a well behavior. So it's a demonstration time. I want to show two demonstrations. The first demonstration is about Rclex on knobs within the network. I have two Raspberry Pi in front of me. One has a native Ubuntu and ROS2 environment. And one more is the other has Rclex knobs installed and an analog joystick attached. The joystick value obtained by knobs is published as a topic to Turtle Sim. I need to execute two commands, Rclex on knobs.joystick start link and start publish. Yeah. Now, these two computers can connect each other, and joystick value, I can control the behavior of Turtle by joystick value. This is the first demonstration. And for the second demonstration, Zeno is up for grabs. We have a Zeno router running in a VM deployed on Azure. I will control the Turtle nodes running in Japan by using the Zeno DDS plugin. This means that Rclex message between nodes will go beyond the Pacific Ocean. So it's time to demonstration. I want to introduce Shintaro. He's a project researcher in my laboratory. So what time in Japan?
Okay, good morning, everyone. I'm joining from Japan. Okay, I share my screen. Okay.
Maybe Japan is around 8 a.m. So I guess he may be a little angry to help with this demonstration so early in this morning. So please share your screen, okay? I got it?
Okay, can my screen?
Yes. Okay. And there are three terminals. In the first terminal, he is connecting to an Azure VM and launching the Zeno router. And in the second terminal, Shintaro is running Zeno DDS plugin on his laptop. Of course, I don't know the IP address of his laptop. Now, please bring up the Turtle Sim node on your laptop. Okay. I execute two commands again and operate the joystick. Can you hear? Can you see? Oh, okay. Rclex message go beyond the Pacific Ocean now. Thank you very much. Oh, this is a backup. I'm happy that I didn't use it. So wrapping up for my talk, I introduced our research activity for autonomous node communication for Elixir ecosystems. Rclex could perform autonomous node communication within the network. Knobs could realize bare minimum and bulletproof runtime for the Rclex application. And Zeno could achieve autonomous node communication between different networks. We don't think that the this method present here is the best one. You may find that we need to know IP address of Zeno router. It means that our journey is still work in progress. There are many ongoing and upcoming work to do. So the evaluation is somewhat important, and the comparison with other communication module methods such as ROSI and Phoenix PubSub is necessary. The source code of Rclex and Rclex on NAVs are published on GitHub. If you are interested in our activity, please give your star on our GitHub repositories. And if you can help our activity with your knowledge or skill, any issues and pull requests are very welcome. Please check it out. Thank you very much